Hello and welcome to EGN 3613. In this session, we will address the engineering economic decisions, going through the process of decision making and the role of engineers in business. In addition, we will address the different types of strategic decisions and the fundamentals of engineering economics. So why engineering economy is important? It's important because it can assist in defining and formulating a problem. Whether the problem is in manufacturing or service, engineering economy will assist in the formulating and the definition of the problem. In addition, it can assist in estimating or forecasting the outcomes based on the selected solution or alternative, including their financial impact on the company. To define the problem and select the proper alternatives, engineering economy uses a collection of mathematical tools and techniques that simplify the economic comparison. During the analysis, engineering economy takes into consideration uncertainty and risk, especially when estimating for the future. You don't know what's gonna happen in the future, and based on that you have lots of risk and uncertainty associated with that. Another question will be, can we make our decision without these mathematical tools? Yes, we can. It's the people decision or the hunch, but it will be more accurate with better judgment when backed up with mathematical calculations rather than random guess. Analyzing the problem will provide a good insight about the value of solving that problem and the priority compared to other problems. For example, the expansion of I-4 from 2 lanes to 3 lanes between DeLand and Daytona. The project will help people commuting through I-4. In addition, it will help transportation companies using that highway. And it will help the different cities served by I-4, the cities on both sides of I-4, or that I-4 passes through. Based on the outcomes and the population that will be served by the project can be considered as high priority or low priority. And of course, in this case, we have a high priority project that will be funded or supposed to be funded as soon as possible. The different alternatives and constraints will define how the project schedule or how the project should be designed. Understanding the concept of economical decisions will assist even in small decisions, not only in the big decisions. It could be on the organizational level, or it could be on the personal level. For example, on a personal level, which is something that all of us have experienced, we first establish our goal and define the priority. Do we need to buy a bed set versus TV? Which one is more important for us? If the goal was to buy a car, then our objectives will be to target and define maybe economical cars, then find the different alternatives, then set decision criteria, then evaluate feasible alternatives, then select the best alternative. The same applies when dealing with professional organization decision making, which is first define the problem, then define the goals and objectives for that problem. What do you need to accomplish? What do you need to do? You collect relevant information. You define feasible alternatives and make realistic estimates. Then you identify decision-making criteria. You evaluate the alternatives, select the best alternative, then implement the solution and monitor the results. Looking at any problem, you will recognize that it must have at least one alternative solution. even if the solution was to do nothing. Again, and as stated before, we define the problem. Then we identify alternatives. We analyze the alternatives, which will include looking at the cash flow, considering time, interest rate, and the economic worth over time. Each alternative will be evaluated based on the identified criteria and according to constraints and limitation. The proper alternative will be selected, then implemented, then monitored to make sure that that decision or that alternative was the correct decision. And we go back in the loop again. Let's take an example. This is a decision-making process for production engineering example, and the problem that we have or has been defined is that the milling machine has stopped working. So the goal and objectives is to replace that machine as soon as possible. The information that has been provided was that the milling machine cost and required specifications were provided. The alternatives will be to replace the milling machine, and they have 3 different models for that that's available to replace, or to repair the existing machine. The cost and functionality of buying or fixing will be compared. In addition, the cost and functionality between the 3 recommended models will be also compared, and an alternative will be selected. In this case, the decision was to replace existing machine with a newer model. The last step will be to purchase and install the selected machine and monitor the outcome. In large-scale projects with benefits to the community and population, the problem will be weighed differently, and other factors will be considered, such as political reasons and cost-benefit analysis. It will not be looking at the budget and the cost. It will be looking at how much would that benefit the community or the society versus the cost that's being spent, which will be taxpayers' money. So in this example, the project is expanding the water production through expanding the new plant or building a new plant, either expanding the existing plant or building a new plant. So the goal is to increase water production. The information that the population growth will increase, and we need to satisfy the growth. The alternatives will be either new well field, or expanding existing, or building a new plant. Although it might cost a lot, the project will benefit large population, and some political reasons might be included, and political pressure might be applied to move forward with the project. At this point, you compare the cost and politics of alternatives. Which one should we go with? And based on the cost and political reasons, the decision was here to expand existing plant and not to build a new plant. And of course, a media tour for the expansion should be made to advertise about the expansion and the reasons for the expansion, since it's being expanded by tax payers. The same thing can be done on a personal level, which could be like, as a simple example, the lease of a car, leasing a car, and you have two choices, Saturn and Honda. So in this case, we have leasing a new car. The alternatives were two choices. It was minimized to just two cars, two different cars, the Saturn and Honda. So the collected information was to gather the technical information and financial data for those two cars in particular, and the choice will be, the alternatives will be either this or that. And then we look at what is the minimum total cash outlay just to get either option, and based on that, the Honda was selected as the car of selection based on the identified criteria. So economical decision has to be made based on the collected information, and the collected information has to be the best information available based on research, based on looking at the cost, the technical aspects or specifications, and after that we can compare the different alternatives thoroughly and with backed up information. Some of the information will be either estimated or forecasted, but in this case we have to understand the uncertainty associated with our prediction. We have to understand that economical decisions are not necessarily time constant, and they might change over time. From identifying the problem to implementing the proper solution, we can see the exact role of engineers in the decision-making process. From the design stage to planning to investment to manufacturing to profit, engineers are involved in decision-making, weighing all the alternatives to be able to provide the return on investment for the company or the organization. Engineers have to justify large-scale projects, especially the ones associated with large amount of money. Engineers create and design projects. They analyze production methods, engineering safety, environmental impact, market assessment. They evaluate the expected profitability and the timing of cash flows, the degree of financial risk. They evaluate the impact on financial statement, firm's market, the value of that firm or the stock in the market. With large-scale engineering projects, there is a need for large investment with longer time to see the financial outcome. It will be also difficult to predict the revenue and the cost associated over time. It will be associated with risk and uncertainties. Unwanted events may be even may happen, like accidents or problems that might pop up during the project. All these has to be taken into consideration when working in large projects with long time commitments. Engineers predict the future through estimating required investment, through forecasting a product demand based on market or population analysis, estimating the selling price for a product that is still under development or in the design stage, estimate manufacturing cost for a new product, or estimating how long would the product serve, which is called product life cycle. There are two factors that define the aspects of any engineering economic decisions. The factors are time and uncertainty. Like we said, over time, the value will change, the value of the material, the value of the company, and that has to be considered. And there are lots of uncertainties and risks that will be associated with any project, and that will be considered. So the economical value of the project will change over time. In addition, there are lots of uncertainties on the outcome with the long-term, large-scale projects. Some of the strategic engineering economic decisions are quality or process improvement, especially in service industries such as healthcare, education, banking, insurance, entertainment, and many others. Other decisions could be related to the release of a new product, such as Gillette sensor or MACH 3, and we'll talk about that in a minute. It could be also buying a new machine or replacing an existing machine that is obsolete or out of order, just stopped working and we need to replace it. And it could be a decision related to cost reduction, such as lowering the cost of airline operations. This figure shows an example of process improvement at the same time involved the cost or decision of buying additional robotic tailors. So to justify the expansion, engineers have to look at how many genes need to be sold and during what time or what period of time to break even with the associated cost of that expansion. You are adding a new machine, you are paying for that new machine, but how much do you need to sell to break even with what you bought, with what you invested, what you spend in money? In this figure, it compares two suggested healthcare plans, the traditional and the new plan, to evaluate which plan will be economically more viable. Choosing the material that will be used in the auto body panel will dictate the manufacturing process for an automotive body panel, as well as the manufacturing cost. The table here shows a comparison between selecting plastic and selecting steel sheet as auto body panel. And you can see the different, not only in the cost of the material, but also in the machining and the tooling items. Although the cost of the plastic is more expensive and the cycle time is more than the steel, we have to consider other factors to generate the final judgment or decision. Is it the time to replace the old machine? This is one of the questions that engineers should actually answer after analyzing existing information, considering the company constraints and the associated risk with the decision. They should evaluate alternatives, then make the proper decision. Sometimes you have to look at also, like we said before, political and environmental issues, ethical issues that will be associated with buying or replacing that machine. Engineer's economical decision will answer the question. Not only that, it will answer, if not now, if I'm not replacing it right now, when should I replace it? So it will answer the yes or no replacement, and it will if no, then it will answer when should be the replacement done. When adding a new product to the company's line of production, there are lots of factors to be considered. Do we have the right equipment for production? Do we have the space? Do we have enough money? What's the risk and the uncertainties associated with that? Shall we build a new facility? Is it worth spending the money? All information will be analyzed and the proper decision will be made based on the evaluation for existing alternatives and the selection criteria. A good example of a new product is the introduction of Gillette Mach 3. The company invested around $1 billion in the new product. And the new product was priced 35% higher than the Sensor XL. Now, would the consumer pay extra money for better results? If the blade has longer life time, wouldn't that affect future sales? If it can last more, then less people will buy, and then that will affect sales. So what do we need to do in this case? Another decision will be, like we said, the cost reduction, and one of the questions, should a company buy equipment to perform an operation that is being done manually, like automation of that process? Remember that this might be a huge investment in order to save more money later. So yeah, I can do the automation and I can replace the manual labor with automated machine, but with a huge investment, that's a very hard decision to make, especially if the return on investment will not pay back until like many years ahead. So we have to consider all the information that's been provided, the uncertainties, and based on that make our final decision. From previous slides, we can conclude that the fundamental principles of engineering economics are a nearby dollar is worth more than a distant dollar. All it counts is the differences among alternatives. Marginal revenue must exceed marginal cost. Additional risk is not taken without the expected additional return. So the value of the dollar decreases over time, which should be considered in all economical decisions. Some information could be irrelative or irrelevant to the engineering economic decision. Others will define what alternatives to choose. As shown in this figure, the marginal revenue must exceed marginal cost. And if you are considering the selection of the high risk alternative, then it should be or it should have additional return, otherwise should not be selected. So in summary, the term engineering economic decision refers to all investment decisions relating to engineering projects. And the five main types of engineering economic decisions are service improvement, equipment and process selection, equipment replacement, new product and product expansion, and cost reduction. The factors of time and uncertainty are the defining aspects of any investment project. That will be all for this session. If you have any questions, you can either email it through Falcon Online, or you can call me, or you can come to my office during office hours. Thank you and have a great day.